Hello friends, IBM is here with another episode of Learning Physics. Remember, I'm solving past paper questions, multiple choice past paper questions, and we are dealing with AS Physics, physical quantities, units, and measurements. This is part 2 of this video. I made part 1 was very short because I was trying to learn how to use the new application. I thank my friend, I think he's in Pakistan, who advised me on this new application, and I'm enjoying using it. Thank you very much, my friend. May God bless you. May you succeed in your exams, and may you enjoy these videos as you have always done. Okay, so in part 1, I think we stopped on this question here, and in part 2, I want us to start from the same question. Okay, we can start with the next question. I hope this font is enough. Let me put that. Okay, I hope that is enough. Okay, what is an alternative way of expressing energy of 43 joules? You should know the prefixes right from the smallest up to the largest. Remember, we have pico, that is 10 power negative 12, followed by nano, 10 power negative 9, followed by micro, 10 power negative 6, followed by milli, 10 power negative 3, followed by cent, 10 power negative 2, followed by dec, 10 power negative 1, then followed by we have the kilo, that is 10 power 3, we have mega, 10 power 6, we have giga, 10 power 9, and we have tera, which is 10 power 12. These are the prefixes that you need to know every time. So here we have been given joules, so this is 10 power negative 1, so 43 joules is going to be 43 times 10 power negative 1 in joules. To remove a prefix, you multiply by its value, but then we want to check. We shall start by bringing in milli. So to bring in a prefix, we divide by its value. Milli is 10 power negative 3, so I will say here divide by 10 power negative 3. So 43 exponent negative 1 divide by 1 exponent negative 3. That is 4,300. So this is 4,300. And this is the same as 4.3 times 10 power 3 millijoules. So this is 4.3 times 10 power 3 millijoules. I think this is going to be the correct answer. A tennis ball is hit so that it leaves the racket with velocity v at an angle theta to the horizontal. The vertical component of the velocity is vy. What is the magnitude of the horizontal component of v? So the vertical component is vy, so let the horizontal component, I will call it vx. So for the horizontal, we resolve horizontally. So vx is going to be equal to v cos of theta. But then they have told us the vertical component is vy. Let's find vy in terms of v. So vy, we resolve v in the vertical, and vy is equal to v sine of theta. So we have to combine these two. Expressions. So what is the magnitude of the horizontal component of v? So if I make a v the subject in this expression here, or I make v the subject in this expression here, and I substitute in this one. Alternatively, even if I don't do that, I can use let me just use Pythagoras theorem, because if the vertical component is v, then let me just use Pythagoras theorem, because I don't see any of these, because v sine theta is vertical component, vy cos theta, that is not a horizontal component, vy sine theta, that cannot be horizontal component. So it means the only option I have is to use a Pythagoras theorem. So vy is in the vertical. I want to find vx. So this is v. By Pythagoras theorem, vx squared plus Vy squared should give us V. So since I want Vx, I'll make it the subject. So this is V squared. So I'll make it the subject. So Vx squared is going to be V squared minus Vy squared. Then I'll find the square root. So Vx is going to be the square root of V squared minus Vy squared. That means our answer is going to be D. Okay, so these ones will not work because we don't see anything relating to them here. In the horizontal, V is supposed to be V cos. We don't have it here. We have Vy cos theta. So this is wrong. So the only option we have is D. For a cathode ray oscilloscope, screens each display a waveform. The screen and the time-based setting of each CRO is shown. Okay, so they have given us the time-based and the screen display. Which screens show waveforms of the same frequency? Same frequency. Let's verify. So let's find, remember period, frequency is equal to 1 over period, and this will be 1 over the length representing one cycle and the time-based setting. So let's start with the first one. So the length representing one cycle is 1, 2, 3, 4. There are 4 divisions. So the frequency is going to be 1 divided by 4 divisions. So 4 times, each division is 0.02 seconds. So this will be 4 times 0.02. And this gives us 1 divided by 4 times 0.02. That gives us 12.5. So this is 12.5 for the first one. Then for 2, we have the frequency will be equal to 1 over the length representing one cycle. So one cycle starts from here up to here. That is 1, 2. So those are 2 divisions times the time-based setting times the time-based setting, and the time-based setting is 0.04 seconds per division. So let's check. So 1 divided by 2 times 0.04. This gives us 12.5 hertz. So without checking any other, because there are only 2 answers given for each, it means B will be wrong, C will be wrong, D will be wrong, and it means our answer is going to be only A. I may not check the rest, but I can also check one of them and I see. Let me check 3. Let's check 3. So the frequency is going to be the period is going to be represented by these 2 boxes because one cycle stops here. So the frequency is going to be 1 over the number of boxes is 2 times the time-based setting, which is 0.01. So 1 divided by 2 times 0.01, that gives us 50. So this means wherever there is 3, it is out. You can even check 4. The period is going to be represented by, one cycle is going to be represented by that number of divisions, 1, 2, 3, 4. Those are 4 divisions. So the frequency is going to be 1 over the period, which is 1 over the length representing one cycle, that is 4 divisions, times the time-based setting, which is 0.08. So we can check 1 divided by 4 times 0.08. That gives us 3.125 hertz. So it means 4 is also out. Therefore, our answer is A. A paper book contains 210 sheets of paper. Its thickness is measured with a ruler as shown. What is the average thickness of one sheet of the paper in the book? So this is IGCSE work. So we take a reading at this point here. The scale is 0.1. So this reading is 0.9, I guess. And take the reading here. This is 3.5, 3.6. So this is 3.6. So the thickness there for all those pages is 3.6 minus 0.9 in centimeters. 3.6 minus 0.9 in centimeters, which gives us 2.7 in centimeters. So we want the average thickness of one sheet. So we just divide this by the number of sheets. So 2.7 centimeters divided by 210. So we divide the answer by 210. and this is giving us 0.13. So this is 0.13 centimeters. So our answer is 0.13, 0.013. So our answer is going to be A. What's the unit of resistance? You just look for a formula which has resistance. Any formula that you think is easy to use for resistance. I can use power equals to I squared times R. Find resistance. It means the resistance is going to be power divided by I squared. We know the base units of I squared will be ampere squared. That one is fine. And then for power can be energy over time. And energies can also be work done, because work done is energy in motion. So the units of energy, we have those of work done, force times distance, that will be kilogram, meters per second squared times meters. So it becomes kilogram meters squared per second squared divided by time, which is seconds. So the units of power are going to be kilogram meters squared per second power -3. So now it means the units of resistance are going to be kilogram meters squared per second cubed divided by current squared, which is ampere squared. So our unit is kilogram meters squared per second cubed per ampere squared. So our answer here is going to be precisely D. Which list consists only of scalar quantities? Remember, scalar quantities have magnitude only. Acceleration and displacement, force, weight, all those are vectors. This density is a scalar, energy is a scalar, frequency is a scalar, velocity is a vector, distance is a scalar, pressure is a scalar, temperature is a scalar, time is a scalar. So our answer is going to be C. Momentum is a vector quantity. What is a reasonable estimate for the density of sand? The density of sand. Of course, we expect sand to be denser than water, or denser than liquid. And for a liquid such as water, its density is 1000 kilograms per meters cubed. So we expect the sand to be denser than the liquids. We expect sand to be denser than the liquid. So this one is smaller. No, let's check this. Let's change them to the same unit. 2 times 10 power 2 grams per centimeter is the same as 200,000. We just multiply by 1000, so it is kilograms per meters cubed. This one is 2000, then you multiply by 1000, kilograms per meters cubed. And this one is, let me first rub off this one here because I want space. So we say this is 2000 again times 1000 in the kilograms per meters cubed. This one is just 20 kilograms per meters cubed, and this one is 2000 kilograms per meters cubed. So the answer is going to be D, because this is extremely large, very large, and this is too small. So our answer is going to be this one here, slightly above the density of a liquid. Which physical quantity could have units of Newton second squared per meter? So we can convert this in a more familiar unit. Newton is force, which is kilogram meters per second squared, and then times seconds squared, then times meters. So second squared and per second has cancelled. So this is going to be, this is per meter. Per meter and meter has cancelled. We go back to kilograms. So that means our answer is going to be the mass. We only remain with the mass, the unit of mass, which is kilogram. A velocity vector is shown. A velocity vector is shown. That is the velocity vector. What are the components of the velocity vector in the northerly and in the easterly direction? Northerly and easterly direction. What are the components of the velocity vector in the northerly and in the easterly direction or directions. Okay, so in the northern, it means we are going to resolve in vertically, so that will be 75 cos of 30. How do we see that is cos 30? Because we want to, the angle is between with the vertical, I can draw a horizontal line here, and I make this a right angle triangle. In the north, this is the value that we want, V in the vertical. It is in the adjacent, and this is in the hypotenuse. So if I consider adjacent and hypotenuse from SOHCAHTOA, if I consider the adjacent and the hypotenuse, that would be automatically cos. That's why I have 75 cos 30. So 75 cos of 30, that is 64.9, which is approximately 65. So that is 65 in the vertical. So in the vertical, in the northerly direction, it should be 65, which eliminates A and B. Then in the horizontal, it is automatically going to be sine using the same angle 30, or it will be cos using the angle here, which is 60 degrees. So this was in the vertical. In the horizontal, it is either 75 sine of 30, which is going to be half of 75. 75 sine of 30, sorry, that is 37.5, approximately 38. Or it will be 75 cos of 60, which is still going to be 38. So in the vertical, in the horizontal, it should be 38, meaning D is out. So our answer is going to be C. What is the reasonable estimate of the volume of an adult person? I think the volume of an adult person is 0.10 meters cubed. Why have I taken that to be the reasonable estimate? Somebody may be wondering, why should I take such as the reasonable estimate of the volume of an adult person? Okay, the easiest way to look at this is to think of a person and compress the person in maybe a rectangular shape, and try to estimate the vertical height of a person. For example, let's say the tallest person is 2 meters. Let's say the person is 2 meters, and I will just estimate the width. That is, if you are standing together with everything, I will estimate the width to be approximately, let me say 30 centimeters is going to be big. I will just take 20 centimeters. Let me take 20 centimeters, that is 20 divided by 100, 0.2 in meters. That is my width. Let me estimate the thickness, that is if viewed from the sides. Approximately, on average, I'll just take an average value of around, I'll take 10. 10 is very large. I'll take, let me take 8 centimeters, which would be 0. That is 8 divided by 100, 0.08 meters. So this is going to give us a product of 2 times 0.2, then times 0.08, which gives us 0.032 meters cubed. So notice that I've taken these estimated values, and they have given me 0.032 meters cubed. That means 0.5 meters cubed is very large, 1 meter cubed is very large, 2 meters cubed is very large. So the smallest which could be very close to this is 0.1. So this would be a better estimate than the rest, because for a person, I've been estimating the dimensions of a person, compressing them into a rectangle. It has given not a rectangle, into a cuboid. It has given me this value here. So the most probable estimate is 0.10 meters cubed. Alternatively, you can check this by trying to find the mass. By trying to find the mass, that would mean you would have to try, and the density. That means you will try to estimate To find the mass, we try to use to think of the density. So volume is equal to, or mass is equal to density times volume. Let us assume the volume is 0.10 meters cubed, and let us assume the average density of a person to be approximately, if you look at blood, if a liquid like water has a density of 1000 kilograms per meters cubed, then blood could be a little bit denser than water. So let me say the density of blood is approximately, let me just take 200 to be the density. So this will give me 0.1 times 200, which would give me a mass of 20 kilograms. Of course, this is very small for an adult person, but let's check if we used a volume of 0.5, what is the average density of anyway, I'll not take this has not taken into consideration the average density of the soft tissue and so on and so forth, but I'm very sure if I could estimate carefully the average density of a person, then I would get a mass close to the mass of an adult person. So in precisely, I'm saying the average, or the best estimate for the volume of an adult person is going to be 0.10 rather than the rest. Which combination of units could be used for expressing the power dissipated in a resistor? Power, combination of units. So we know that power is work done over time taken, and work done is force times distance over time taken. Force has units as newtons, distance has units as meters, and time has units as seconds. So the question is, which combination of units could be used for expressing the power dissipated in a resistor? Therefore, our answer here is automatically going to be D, which is reading as Newton meters per second. A force of 10 newtons and a force of 5 newtons act on an object. The angle between the forces is 150 degrees. The resultant force on the object can be resolved into a pair of perpendicular components. Of course, we can see that the resultant can be resolved into a pair of perpendicular components. Which row shows numerical expressions for a possible pair of perpendicular components? 5 Newton is in the horizontal to the left, so to the right, this angle here is 180 minus 150, which is 30 degrees. Resolving 10 newtons to the horizontal will be 10 cos of 30, and resolving 10 newtons to the vertical will be 10 sine of 30 degrees. So it means in the horizontal we have either 10 cos 30 or minus 5, or 5 minus 10 cos 30. Let's check that. 10 cos 30 minus 5, 10 cos 30 minus 5, or 5 minus 10 cos 30, that is in the horizontal. So we have 10 cos 30 minus 5, 10 sine 30. Let me check this again. 10 cos 30 minus 5, and in the vertical we have 10 sine 30. So which row shows expressions for a possible pair of perpendicular components? 10 cos 30, I have here 10 cos 30 minus 5 in the horizontal axis, and in the vertical I have 10 sine 30. So I will start with the vertical. 10 sine 30, I don't have 10 sine 30 in the vertical here. So I know that the vertical component should be sine 30 and the horizontal component should be cos of 30. So I'll just look for, ignore the factors that I used to multiply here to arrive at the correct answer. The vertical component should be sine 30. That means I ignore these ones. I mean the horizontal component, yes, the horizontal component should be cos and the vertical component should be sine. So the vertical component should be sine, so I ignore these three. And the horizontal component must be subtracted by a certain value because there is 5 newtons to the side and it has a horizontal component of cos 10 cos 30. So it means our most appropriate value, of course this is showing 10 sine 30, 10 sine 30, but of course we have already eliminated A, B and D because the vertical component is supposed to be sine 30 only. There's no any other force in the vertical, so our correct answer is this. Now somebody may be wondering how it becomes 10 minus 5 cos 30 and 5 sine 30. Note that 10 sine 30 and 10 cos 30, they have a common factor of 10, and it is equivalent to dividing this by 2, so that is 5 sine 30, and this would also be 5 cos 30, and that 2 I would multiply it with the other one. Since in the vertical there is no any other force in the horizontal, in the vertical, so it will be like 0 times that 2, or 10 sine, it will be 5 sine 30, 5 sine of 30 minus 0 times 2, that factor of 2 that I've divided with, and in the horizontal it can be 10 cos, or 5 cos 30 minus 5 times that factor 2, or it can be 5 times 2 minus 10 minus 5. I'm saying this 5 times 2 because I divided by 2 to get 5 cos 30. So this 5 times 2 minus 5 cos of 30. So it means in the vertical I will have 5 sine of 30 minus 0, and in the horizontal I'll have 10 minus 5 cos 30. That is just simple, that is just algebra, not physics. So it means our answer is going to be C. What is not a reasonable estimate of the physical property indicated? A reasonable estimate. 2 times 10 power 3 watts for the power dissipated by a heating element of an electrical kettle. I think that is fine because the power is given, the power for domestic use is around 2.5 kilowatts. So I think this is fine for the electric kettle. 4 times 10 power 2 meters cubed for the volume of a swimming pool. I think this is fine for the volume of a swimming pool. Then 5 times 5 Newton seconds for the momentum of a lorry moving along a road. People may want to check this. Here you know the density of water, you can check the mass. And then you try to evaluate using the mass, because mass is density times volume. If the volume is 4 times 10 power 2, and then you multiply by the density, which is 1000, you notice that the mass is reasonable for that water in a swimming pool. Then 5 times 10 power 5 Newton seconds for the momentum of a lorry along a track. So we can check it by trying to find the mass of that lorry. They've given us momentum. Momentum is mass times velocity. It is moving along a road. So the momentum is 5 times 10 power 5. The mass we are going to check by using the mass. So let's estimate the velocity of a lorry along a road. Let's say it is traveling at 60 kilometers per hour. It is traveling at 60 kilometers, that is times 1000 per hour, that is 3600. So that we have meters per second. So let me try to find m and see if the mass we get is reasonable. So 5 exponent 5 times 3600 divided by 60 times 1000. Yes, 30,000 is a reasonable mass for a lorry. 30,000 kilograms is a reasonable mass for a lorry, so this is a reasonable estimate. Then that means our answer is going to be D. 6 times 10 power 2 newtons for the weight of a fully grown racehorse. let's see. A fully grown racehorse of weight, let's find the mass. Weight is equal to m times g. So the mass is going to be the weight, which is 600 divided by g, which is approximately 10 or 9.81. So 600 divided by 9.81, this gives us 61, approximately 61 kilograms. So this is a very small mass. You cannot be you cannot have, some of you could be having a mass greater than 61 kilograms. So there is no way you can have a mass greater than that of a horse, a fully grown race horse. So it means this is not a reasonable estimate. It gives a small mass. Which quantity could have units Newton meters per volt? Newton meter per volt. Newton meter per volt. We can check this. A Newton refers to Newton will be okay. So Newton, that is kilogram meters per second squared times meters, then times per volt. So this is kilogram meters squared per second squared, then times per volt. This is a unit of energy, so that is energy, then times per volt, or divide by 1 volt, that is 1 over V. And I think this is going to be charge, because we know that PD is equal to the energy per unit charge, and that means a volt, kilogram meter squared per second squared divided by a volt, that is going to be a unit of charge. So this is going to be charge. An object is acted upon by two forces, 10 newtons in the vertical direction and 6 newtons at 40 degrees to the vertical, as shown in the figure. What is the resultant force acting on the object? So before we do the calculation, we can predict that our answer is going to be D. Our answer is going to be D by looking at the direction. However, if we try to complete this diagram or the parallelogram using the parallelogram rule, I try to complete this. I'm transferring this vector here to the other head, the head of 10 newtons. So I have that one, and I transfer this vector here without changing its direction. So we notice that the resultant will be around here. The resultant will be there. So that means this is automatically indicating that these two are automatically wrong. 15 degrees, 18 degrees from the vertical, those ones are wrong. Let's try to estimate to find which angle does the resultant make from the vertical. Let's just find that. So this angle is going to be 40 degrees, I guess. That is 40 degrees. And if this is 40, we need the angle when the vectors are joined head to tail. So if that angle is 40, this angle is also, if that is 40, this is 40. I think this angle is also 40 degrees. And it means these two angles, the sum of these angles should be equal. These ones should also be equal. So I'll find this. This is going to be total is 360 degrees minus 40 plus 40, which is 80. And I will divide this by 2. So each of these angles is approximately 140. So this is approximately 140. This is approximately 140. Then I will divide again by 2. No, this is 140. This is 140. Okay, so let's first find the magnitude then. Let's find the magnitude using, I will just use the cosine rule since I know the vectors after joining them head to tail. This is 10 newtons, the other one is 6. So R is going to be equal to the square root of 10 squared plus 6 squared minus 2 times 10 times 6 cos of 40. The angle between the vectors when joined head to tail, I think it is 40. If I look at this part of the diagram, the angle between the two vectors, 10 newtons joined to the tail of 6 newtons, the angle between them is 40 degrees. Okay, and if that is true, so this will be cos 40. 2 times that, cos 40. So I'll find this 10 squared plus 6 squared minus 2 times 10 times 6 cos of 40. That gives me that, and I can find the square root of the answer, which is 6.6. So without even hesitation, the magnitude is 6.6. So this is 6.6 newtons. So it means our answer is going to be D. So our answer is automatically D. I may not even check the angle from the vertical, but it is automatically D. An analog ammeter with a range of 0 to 240 milliamperes is connected into an electrical circuit. The diagram shows the ammeter's display. What is the reading? What is the reading on the ammeter? Reading on the ammeter. An analog ammeter with a range 0 to 250 milliamperes is connected into an electrical circuit. The diagram shows the ammeter's display. So this is 1, 2, 3, 4, 5. So this should be 6, 7, 8, 9, and 10. So this is going to be 7 point here between there are 5 small divisions. So 1 divided by 5, that is 0.2. So 7.1, 2.4.6, that is 7.6. So it is reading 7.6. Now the question is, what is the reading on the ammeter? An analog ammeter with a range of 0 to 250 milliamperes is connected into an electrical circuit. The diagram shows the ammeter's display. So it has a range between from 0 to 250. It shows it has a range between 0 to 250 milliamperes, and here we are seeing it is it is actually at 7.6. Now this, remember, the range should be between 0 to 250, and we have to divide this range into what we have here. We have to divide this range 0 to 250 into what we have here, so that we shall be able to arrive at the most appropriate reading of the ammeter, because it measures values of current between 0 to 250 milliamperes, and yet this is the display. So the easiest way is to find how many divisions are there. So this is 5, 10, 15, 20, 25. So there are 50 divisions. So the range of 250 is going to be divided by 50 divisions. So that gives us 250 divided by 50 divisions, that is 5. So this is going to be 5. So each division is going to represent 5 milliamperes. Each division, because the range is between 0 and 250. So each division is going to represent 5 milliamperes. And then now we have 7, that is it 7? No. So at 5 we have, that is 25, 30, 35. At what I called 7.6 is actually, I will just rub off this. What I called 7.6 is actually, this is 25 divisions, 30, 35, 36, 37, 38. There are 38 divisions, so that will be 38 times 5. So we have 5 times 38, which gives us 190. So this is 190 milliamperes. So the reading is 190. Now, I know a layman will look at the reading as 76 milliamperes immediately. But where do you get 76? Yet this is 7.6 according to the scale display. But since they told us that the range is between 0 to 250, then we are going to divide this display here. I mean the range of the current measure with the display. That's why I said I try to find what each division represents on the scale of milliamperes. And I noticed that when I get to 50 by the total number of divisions between 0 and 10, which were 50, I got 5 milliamperes. Then I counted total number of divisions between 0 and where the pointer is. They were approximately 38. I multiplied by 5, which gives me 190 milliamperes. So my answer is going to be D. What is a reasonable estimate of the kinetic energy of an Olympic athlete sprinting in a 100-meter race? This question appears several times, and if you have seen it several times, you'll notice that, you'll be able to verify that the answer is actually C. How? What is the reasonable estimate of the kinetic energy? So kinetic energy is a half mv squared. So we are just going to equate this to the values of kinetic energy that we have there, and we estimate the mass. The mass is going to be the kinetic energy multiplied by 2, always divide by v squared. Of course, an athlete, let's say, is sprinting very fast. The average speed is going to be 10 meters per second. Let's say the speed is approximately 10 meters per second. That is if he's running like Usain Bolt. So checking the first value of energy, which is 40. Let's see what mass it gives us. So this is going to be 2 times 40 divided by v squared, which is 100. So this gives us a negligible mass. That one is not going to be possible. No person has a mass of 0.8 kilograms. Then we check the second one, 2 times 400 divided by v squared, which is 100. 8 kilograms still very small. Let's check 4,000 times 2 divided by 100. So an athlete can have a mass of 80 kilograms. So that means this makes sense. We can check the last one. 2 times 40,000. 2 times 40,000 divided by v squared, which is 100. No athlete can run with 800 kilograms, so that means the most appropriate answer is 400 joules. 4,000 joules. What is the unit of momentum? Remember, momentum is mass times velocity, and momentum can also be force times time, that is change in momentum or impulse. That means our most appropriate answer is going to be Newton seconds. The change in momentum is force times time, which is going to be mass times change in velocity. So kilogram meters per second, that is just force. Newtons per second, that is force over time. Newtons times seconds, that is force times time. So our answer is going to be C. What is the horizontal component of the force shown? So we resolve this in the horizontal, and it will be 20 cos of 30. Sorry, 53. 20 cos 53. And from our calculator, 20 cos of 53 is giving us 12 point something. That means our answer is going to be A. The diagram shows two readings on a micrometer. What is the difference between the two readings? Okay, we want a difference between the two readings. So here, when I look at this full scale, it means each division is, or between 0 and 5, there are 10 divisions. So each division is going to be 5 over 10, which is 0.5. So this is going to be 0.51, 1.5. So the reading here is 1. On the main scale, it is 1.5 plus. On the scale which rotates, this is 10, 11, 12. 10, 11, 12. So the line which is perfect in line with this one is this one here, which is the 12th. So that will be 12 divided by 100. So the reading here is going to be 1 point. I think this is 0.12. So I think this is 1.6, 1.62. And the reading here we have 10, 11, 12, 13. So we are seeing 13 there. We can't see the next division. So 13 plus, this is 45, 46. So this is 46. So this will be plus 46 over 100. So that is 0 point. So this is going to be 13.46. That is 13.46. So we want the difference between the two readings. So we have 13.46 minus 1.62. So 13.46 minus 1.62, that is 11.84. So the answer here is going to be B. For which quantity is the magnitude a reasonable estimate? A reasonable estimate. Okay, 500 picohertz frequency of radio waves. 500 picohertz. Remember, 500 pico is 10 power negative 12. So this will be 500 times 10 power negative 12. Frequencies of radio waves cannot have a negative power. So this one is negative power of 10. That is wrong. The mass of an atom, 500 micrograms. The mass of an atom, 500 micrograms. That is 500 times 10 power negative 6 grams. 500 exponent negative 6. This is equal to 5 times 10 power negative 4. Then I multiply by 10 power negative 3. That will be 5 times 10 power negative 7 in kilograms. If the mass of a nucleus is 1.6, I mean the mass of a proton alone is 1.6 times 10 power negative 27 kilograms. It means this mass is too big for the mass of an atom, because the mass of an atom will be extremely small. It will be extremely small. It could even be of the order 10 power negative 26, 27. So that is wrong. Then the Young modulus of a metal is 500 kilopascals. Let's see, 500 kilo is 10 power 3 pascals, which is 5 times 10 power 5 pascals. The order of Young modulus for metals is, I think it is 10 power 10, 10 power 11. So that means it should be at least of giga order. So this one is also not correct. The wavelength of green light is 500 nanometers. From Richard of York gave birth in vain. Red is the longest wavelength, which is 700 nanometers. Violet is the shortest, which is 400 nanometers. I think it makes sense to say that green is 500 nanometers approximately at the center of these, or the average of these two. 400, 700 plus 400 divided by 2. It is almost at the center, so we can say that this is a reasonable estimate. The speed of a wave in deep water depends on its wavelength L and the acceleration of free fall G. What is a possible equation for the speed V of the wave? A possible equation for the speed V of the wave. So we are just going to check the units here. We shall check which equation has units that give us, that are units for speed. Let's start with the first one. G is acceleration due to gravity, which is in meters per second squared, times L is wavelength, which is in meters, and then 2 pi has no units, and this is under the square root. When you find the square root here, it will be meters per second, which is a unit of speed, so the answer is most likely going to be A. You can check why not B. For B, this is going to be meters per second squared, then times meters, which will be meters squared per second squared. That is going to be V squared, not speed. So this is out. You can check the rest. The diagram shows two vectors, x and y, drawn to scale. They are drawn to scale, meaning I can measure their lengths. I can measure their lengths because they are drawn to scale. If x is equal to y minus z, which diagram best represents the vector z? Okay, which diagram best represents the vector z? So we also notice that if I get x and I add z, I should be able to get y, and x should not change direction and y should remain in the horizontal. So if I get x and I add z, I should be able to get y. Y should be pointing to the right. Y should be pointing to the right. So if I get x and I add z, if I add this one, if this was z, I add it to x, there is no way it will point in the horizontal to the right, so this is out. If I add z, if this was z and I add it to x, there is no way I would get. Okay, if I fix x and I add z to it, or I fix z and I add y, I mean x to it, there is no way I would get y in the horizontal to the right, so this is wrong. If I fix z vertically downwards and I add x here, if I fix z vertically downwards and I add x, if I fix z vertically, remember these are measured to scale. If I fix z vertically downwards and I add x, so this will be z and I add x. When you compare this magnitude and this one, you notice that this will be very small. You can try this with a ruler, draw a vertical line. You notice that this magnitude will not be correct, so this will also not be right. So it means D is also not very accurate. We can check A. If I fix x and I add z, when you look at, if you were to measure these magnitudes, on x you add z, you notice that you'll be able to get y in that direction there. So it means our answer is going to be A. If that is z and you measure, just bring y, measure the length of y using a ruler and bring it here, and try to measure the length of x using a ruler and bring it here. You notice that if I get x and I add z, I will be able to get y because they said they were drawn to scale. So our correct answer is going to be A. So you can try to measure these lengths using a ruler because they are given to scale, and then compare. If you combine them and you see that they give you the resultant that is required. So you can try to measure if you printed this in hard copy. A student intends to measure accurately the diameter of a wire known to be approximately 1 millimeter. That is quite small, 1 millimeter. And the internal diameter of a pipe known to be approximately 2 centimeters. Of course, 1 millimeter, to measure such a diameter accurately, you will use a micrometer screw gauge. And the internal diameter, there is no way I will use a micrometer screw gauge to measure the internal diameter because it is the vernier caliper which has inner jaws and outer jaws. So I will use a VC or vernier caliper. What are the most appropriate instruments for the student to use to make these measurements? So we have said a micrometer screw gauge for wire and vernier calipers for internal diameter. So the answer is going to be C. cyclist has a speed of 5 meters per second and a small car has a speed of 12 meters per second. Which statement does not give a reasonable estimate? Which statement does not give a reasonable estimate? Okay. A, the kinetic energy of the cyclist is 1 times 10 power 3 joules. B, the kinetic energy of the car is 7 times 10 power negative 4 joules. And C, the momentum of a cyclist is 4 times 10 power 2 joules. The momentum of the car is 2 times 10 power 5 kilograms meters per second. Does not. So the answer is going to be D. We can check. How do I check this? I am going to begin by estimating the mass of a cyclist. Think of a person and the motorcycle itself. The mass is going to be relatively large. Let's check this value of kinetic energy to see what mass does it give us. They gave us even the speed. So kinetic energy is a half mv squared. So I make m the subject. So it will be twice kinetic energy divided by v squared. So I'm going to check the mass given, the mass which I will get using the energy for the cyclist whose speed is 5 meters per second. So this will be 2 times the energy, which is 1 exponent 3, divided by v squared, which is 25. So that is 80 kilograms. So this one is the mass is 80 kilograms, and that makes sense for a cyclist. Then the second one is 7. It is for the car. So 2 times the kinetic energy, which is 7 exponent 4, divided by the speed of the car, which is 12 squared. That is fine. A small car can have that mass, approximately 1,000 kilograms. So this is giving us approximately 1,000 kilograms to one significant figure. A small car can have that mass. Then the momentum of a cyclist. Remember, momentum is mass times velocity. So we are still finding the mass. Mass is going to be momentum over velocity. So momentum of the cyclist, 4 times 10 power 2, which is 400, divided by the velocity, which is 5. That is 80, so still this makes sense. It gives us a mass of 80. And then the last one, the momentum is 2 exponent 5 divided by the speed, which is 12. Sorry, 2 exponent 5 divided by the speed, which is 12. That gives us approximately 20,000 kilograms. That is not the mass of a small car. It is almost a truck or a trailer. So this means this is not a reasonable estimate. Which expression gives an SI-based quantity, charge per unit time? Charge is I times t, then per unit time, then again divided by time. So time cancels, we remain with the current. So this gives us ampere. So the answer is automatically A. Which expression gives an SI-based quantity, which is current, that is going to give us, that is charge per time. We can check force per unit area. Force is mass, maybe times acceleration, and area is per unit area. So this one does not give us a base unit, an SI base unit at all, because there's no any relationship here, because force per unit area is going to give us pressure, and pressure is not a base unit. Mass per unit volume, that is density, it is not a base unit, it is a derived quantity. Work done per unit distance, that is also not a base quantity. Which list contains only scalar quantities? Displacement is a vector, a scalar. So the answer is going to be B, only scalar quantities. Momentum is a vector, velocity is a vector. Which quantity with its unit is correct? Acceleration, that is not correct, should be meters per second squared. Electric current, that should be amperes, not per second. Electric potential difference across the battery. PD is equal to energy per unit charge. which can be joules per coulomb. So I think this is going to be correct. This is correct. Kinetic energy is newtons per meter squared. Energy is work done, which is force. That is newtons. Force times distance. So that will be Newton meters, not newtons per meter. So this is also wrong. So we remain with C. Which two units are not equivalent to each other? Not equivalent to each other. I will check only a few. I will not check all of them. Let me check D because these ones I'm familiar with them. I think the answer is going to be D. Let's check. Pascal is a unit of pressure, which is force over area. That is force kilogram meters per second squared, divided by area, which is meters squared. When you simplify this, you get kilogram. Meters divided by meters squared becomes per meter, and then you remain with per second squared. So which two units are not equivalent? So D is not equivalent. That one I'm very sure. Pressure is force. Pascal is force over area of pressure, which is force over area. The force is kilogram meters per second squared divided by area, which is meters per second, which gives us kilogram per meter per second squared. So D is not Pascal is not equivalent. We can check the rest. The rest are going to be equivalent. Let's check Newton seconds. This is force times time, and this is mass times velocity. That is all momentum. Because no change in momentum is force times time, which is equal to mass times change in velocity. So these will be having the same unit. So the rest are equivalent to each other. And lastly, for this video, a wave has frequency of 5 gigahertz. What is the period of the wave? What is the period of the wave? So 5 gigahertz. So frequency is going to be 5 times 10 power, because giga is power 9. So the frequency is 5 times 10 power 9. Then we know that period is equal to 1 over f, which is going to be 1 over 5 times 10 power 9. So 1 divided by 5 exponent 9. So this is 2 times 10 power negative 10 seconds. That is the period. And we want it in, we can check which of these ones is correct. And I think the answer is going to be A, because to bring a prefix, we divide by its value. So if I check pico, 2 times 10 power negative 10 divided by 10 power negative 12 for pico. So that is divided by 10 or 1 exponent negative 12. That gives us 200 picoseconds. So the answer is going to be A. Okay, let part 2 stop there. We shall meet in part 3. Bye bye.